This video is about derivatives of logarithmic functions. I'll start with the rule for the derivative of natural log of x. So I'm going to try this example here, which says find the derivative of 6 times the natural log of x. Now the 6 is just a constant which can come up front. And we'll just need to take the derivative of the natural log of x now. According to the rule above, the derivative of natural log of x is just 1 over x. So we get 6 over x. So the natural log has a base of e, and the common log has a base of 10. Whenever we have a log of a base that's not e, then we want to use this rule. Okay, so I'll pull the constant out front. When we have a log whose base is not given, it's assumed to be a 10. And so what I'm going to want to do here is use the rule above, and we'll use a b of 10. So it's going to be 1 over x ln 10. Now we can bring our constant back in, and we'll get 8 over x ln 10. Now let's find the derivative of natural log of 2x. This is going to require a chain rule. Let's let g equal 2x. And we're trying to find the derivative of ln g. Well, according to the rule above, that's going to be 1 over g. And because of chain rule, we're going to have to multiply by g prime. So let's do that down here. We're going to get 1 over 2x. You leave the 2x as itself first. And then multiply by the derivative of the 2x, which would be 2. So this derivative ends up being 2 over 2x, which is 1 over x. Lastly, let's find the derivative of log of 3x. It's going to be similar to the one above, except we'll use the rule here. Okay, we want 1 over the argument of the log function, which will be 3x. Then we'll multiply by ln of the base, which here is assumed to be a 10. So 1 over 3x ln 10. But we can't forget to multiply by the derivative of the inside, which would be 3. So interestingly, this derivative reduces to 1 over x ln 10.